The video's premise: CME near miss. What if this solar storm had hit Earth? Highlights a truly critical concern. While Earth's magnetic field and atmosphere offer significant protection from the constant stream of solar particles, a direct hit from a powerful coronal mass ejection, CME, especially one on the scale of historical events like the 1859 Carrington event or even more extreme past events revealed in tree rings, could have severe and widespread consequences for our modern, technology-dependent society. Here's a breakdown of what could happen if such a solar storm directly impacted Earth. 1. Widespread power grid failures. Geomagnetically induced currents, GICs CMEs, carry immense amounts of magnetized plasma. When this hits Earth's magnetosphere, it can cause rapid fluctuations in our planet's magnetic field. These changes induce strong electrical currents in long conductors on the ground, such as power transmission lines. Transformer damage. These GICs can overload and severely damage large, high-voltage transformers that are crucial for electricity supply. Replacing such transformers is incredibly time-consuming and expensive, as they are custom-built and not readily available. Cascading blackouts. Damage to key transformers could lead to widespread and long-duration power outages, potentially affecting entire regions or even continents. The 1989 Quebec blackout, which plunged millions into darkness for 9 hours, serves as a stark reminder of this vulnerability. A more powerful event could cause blackouts lasting weeks, months, or even years in some areas. 2. Disruptions to communication and navigation systems. Satellite interference. Satellites in orbit, essential for GPS, telecommunications, weather forecasting and military operations, are highly vulnerable to charged particles from CMEs. They can experience temporary malfunctions, permanent damage, or even be knocked out of orbit due to increased atmospheric drag. Radio blackouts. Solar flares, often associated with CMEs, release intense bursts of X-rays and UV radiation. This radiation can ionize Earth's upper atmosphere, leading to significant disruptions or blackouts of high-frequency radio communications, including those used by aviation, emergency services, and amateur radio operators. GPS accuracy issues. GPS signals can be degraded or lost due to ionospheric disturbances caused by solar storms, impacting navigation for vehicles, aircraft, and critical infrastructure. 3. Economic and societal chaos. Economic collapse. The financial cost of a major long-duration power outage would be staggering, potentially in the trillions of dollars globally. Industries reliant on electricity would grind to a halt, supply chains would collapse, and financial markets would be severely disrupted. Infrastructure failure. Beyond electricity, a modern-day Carrington-like event could impact water and wastewater systems. Many rely on electric pumps. Fuel distribution. Gas stations and refineries need power. Heating and air conditioning. Essential for comfort and safety. Banking and commerce. ATMs, credit card systems, and digital transactions would cease. Transportation. Traffic lights, electric trains, and air traffic control systems would be affected. Public health and safety. Loss of power impacts refrigeration for food and medication, access to clean water, and the functioning of hospitals. Emergency services would be severely hampered. 4. Increased radiation exposure for certain groups. Astronauts and air travelers. While Earth's atmosphere protects people on the ground from direct radiation, astronauts in space and even passengers on high latitude High-altitude flights could face increased radiation exposure during intense solar radiation storms, which often accompany CMEs. Historical context. The Carrington event, 1859, the most famous historical example. It caused telegraph systems to fail, shocking operators and even setting equipment on fire. Auroras were seen as far south as the Caribbean. If an event of this magnitude were to hit today, the consequences would be far more severe due to our increased reliance on technology. Quebec blackout, 1989, a less extreme, but still significant, solar storm caused a province-wide power outage in Quebec, Canada, due to GICs. 2012 near miss. A CME comparable in strength to the Carrington event narrowly missed Earth in 2012. If it had hit, the effects would have been devastating. Mitigation and preparedness. Recognizing these risks, governments and organizations worldwide are investing in improved space weather forecasting, better monitoring of the sun and predicting CME trajectories to provide more warning time, grid modernization, implementing measures to harden power grids against GICs, such as installing specialized blocking devices, emergency preparedness, developing contingency plans for long-duration power outages and communication disruptions. Research. Continuing to study solar activity and its impact on Earth to better understand and predict future events. While a direct hit from a truly extreme solar storm remains a low-probability event, its potential for catastrophic impact on our modern way of life makes it a significant, near-miss scenario that warrants serious attention and preparation.